So in this class, we are going to discuss about GATE examinations, some information about GATE examination. I'm going to cover machine design topic from mechanical engineering GATE syllabus. So GATE is the acronym for a Graduate Aptitude Test for Engineers. Graduate Aptitude Test for Engineers, conducted by IIT, all IITs in our country. The importance of GATE examination is, so nowadays, all public sector units, they are recruiting engineering graduates through GATE exam only. If you want to get a green collar job in any one of the PSU in our country, you must clear the GATE examination. What are the PSU units means? That is the company owned by partly government and partly people. That is the people buy the share of the particular company, and a part of the share held by the government. That is the public sector units. The example of public sector units, that is CPCL. CPCL means Chennai Petroleum Corporation Limited, NHPC, National Hydropower Corporation, NTPC, National Thermal Power Corporation, then AAI, Airport Authority of India, NHAI, National Highways Authority of India. These are all the few public sector units. If you want to get job in this public sector unit, you must clear the GATE examination. You have to get the required score. The importance of GATE examination is not only limited to that. Apart from get the job in PSU, you can get a job. You can get a opportunity in study your PG courses in IIT, NIT, and a major institution in our country. Suppose you want to pursue a ME program in IIT or NIT, National Institute of Technology. IIT means Indian Institute of Technology. You know that the GATE score is much important. So here you can get the stipend also. So monthly stipend will be given those who are joined this institution. And also, suppose you want to do ME program in Anna University. Here, the Anna University also, with the help of stipend, you can complete your PG course. Right? So therefore, having the GATE exam score, you can get opportunity in public sector units, as well as a chance to study higher higher studies in the premier institution in our country, and also you will get job in the any one of the private bodies. So because the GATE score having much validity, right? So I am going to take the topic, that is machine design. What are the subtopics are there in the machine design subject is, and GATE examination point of view, what are the topics frequently asked in previous year examination is, the first one is the uh, principal stresses, theories of failure, variable loading, springs, temporary joints, permanent joints, gear drives, brakes, and clutches. In our regular courses, we already studied the principal stresses, theories of failure, variable loading, the concept of helical springs, leaf springs, spiral springs. The temporary joint means there is a bolted joint. Permanent joint means that is a riveted joint, welded joint, gear drives, right? So these things are already studied. right? In the same way, we are going to study for to approach to the gate. So that is in the gate examination. So they will ask some in-depth questions. Once you know the concept thoroughly, then only you can answer the particular question, right? So therefore, you have to study in a deep manner for every topics. That is important, right? So number of questions expected from this subject is 5. You can get 5 questions from the machine design subject. You can get a maximum marks from 5 to 10. If you're strong in machine design, in the gate examination, from this part, you can score 5 to 10. The gate examination is other subjects, that is aptitude, certain score is there, and mathematics, certain score is there, and other subjects like thermal engineering, manufacturing processes, heat and mass transfer, right? So these subject also having importance. So you have to cover all the portions, then only you can get a valid and comfortable gate score for your further enhancement. Okay. So these are the basic information about the gate examination I want to share with you. Next, I want to share some information about basics of machine design. The machine design, the first important basic concept is, that is the stress. So it depends upon the loading mechanism, the stress is developed. So that is a tensile stress, compressive stress, and the shear stress, bending stress, right? So it depends upon the nature of load, the stress is produced. Suppose you are applying the tensile load, the tensile stress is produced. The tensile load means that is a pulling force. The compressive stress is produced. Suppose you are applying the pushing force towards the component. The shear stress is produced. In the case of shear force, the shear force is nothing but that is tangential force acting in opposite directions. To tangential force acting in opposite direction, the shear stress is produced, right? So the stress is developed because of the application of load, right? So therefore, the load can be defined as any external force acting upon a part, acting upon a machine component. That is the load. So we can classify the types of load: the dead load or steady load. A load is said to be a dead or steady load when it does not change in magnitude or direction. Does not change the magnitude or direction. The example for a steady load: you are keeping a book on the table. You are keeping a book on the table. The weight of the book is the steady load. The table will stand the book weight. So here there is no change in weight as well as a change in direction. That is called a dead load or a steady load. So the basic example I am giving. So the another example, that is a live load or a variable load. A load is said to be live or variable load when it changes continually. When it changes continually, I usually tell the example, that is a vehicle passing over a bridge. Vehicle passing over a bridge. A two-wheeler passing over a bridge means that is it will give one load. A four-wheeler passing over a bridge means it is a medium load. Suppose a heavy truck passing over a bridge means that is a heavy load. So that is a load is varying continuously. So that is called a variable load. In another category, suddenly applied load or shock load. Suddenly applied load or shock load. So the example, that is a water impinges on the bucket of a turbine. There is a suddenly applied load, or the hammering action. Hammering action, suppose you are applying the hammering force to the component. So that is a suddenly applied load or a shock load. Finally, that is the impact load. The impact load is nothing but the load is applied with a certain velocity. The load is applied with a certain velocity in controlled manner. That is called a impact load. Here, a machine parts resist a load, dead load more easily than a live load, and a live load more easily than a shock load. It obviously a machine part, the dead load it is easily withstand compared with the live load. Suppose you are comparing live load and the shock load, the live load is easily withstand, right? So therefore, the failure will happen in the case of a shock load. So that is the information from this point. Next, I know that I told you that that is the definition for stress in the previous classes, previous regular classes, and that is the tensile stress, compressive stress, and shear stress. So here the diagram is shown that the mechanism of tensile stress. So that is a circular bar or rectangular bar, this one. So here the load is applied, that is a pulling force is applied in the two direction. So because of that, what happened? That is the elongation of the material takes place. At the same time, the material offers resistance to the elongation. The material offers a resistance to the elongation. The resistance offered per unit area, the resistance offered per a unit area, that is called stress. The resistance offered per unit area, that is called a stress, right? Therefore, we can write that is the stress that is equal to and the resistance offered per unit area. Resistance offered per unit area, right? The resistance will be equal to applied load. That is equal to applied load. That is the equilibrium condition. So after that, there is no failure, right? Suppose we are the exceeding, we are applying the load exceeding the strength or exceeding the resistance, then only the failure takes place. Therefore, at the equilibrium condition, you can equate the resistance with the applied load. Therefore, the stress that is equal to load by area. Load by area. That is a mathematical formula, right? So the area is cross-sectional area of the body. Suppose the circular section means the cross-sectional area is pi by 4 d square, and square area means that is a side by side. The rectangular means depends upon the orientation, that is width into thickness or length into breadth, that is depends upon the orientation of the load. So you can take the area of cross section. So the unit for stress is megapascal or Newton per millimeter square. Both will be same. It is the unit for stress. Suppose the compressive stress means that is the equation is same, but the load applied direction towards, that is a pushing force. The load applied direction is a pushing force. So load applied towards the component, right? That is a pushing force. The formula is same. The another term, strain. The strain is nothing but that is the change in length by original length. Change in length by original length. So whenever the component is subject to tensile load or compressive load, the deformation is takes place. The deformation compared with the original size of the original length of the component, the strain is defined. When the system of forces or load act on a body, it undergoes some deformation. This deformation per unit length, the deformation per unit length is known as a unit strain or simply a strain. The symbol for strain is epsilon. The symbol for stress is usually sigma. In some textbook, they are using a small p as a symbol for stress, and a small e is symbol for strain. Right. So here I have used there is epsilon as a symbol for strain. The strain is nothing but change in length by original length. The change in length can be written as that is strain into length. So change in length is delta L, and L is the original length. There is no unit for strain because the numerator also millimeter, or and the diameter also millimeter, or same dimensions. Therefore, the unit get cancelled. Therefore, there is no unit for a strain. Another important fundamental term is Young's modulus. So, as per the Hooke's law, the material is loaded within the elastic limit. The stress is proportional to strain. That is the statement for Young's modulus. So, within the elastic limit, stress is directly proportional to strain. So, it means that whenever the stress increases, the sign is also increases. So here, for removing the proportionality, you are introducing the constant. The constant is called Young's modulus. Therefore, you can write the Young's modulus is nothing but stress by strain. And also, you can write for stress, that is P by A, and the strain, that is a delta L by L. Therefore, the L moves on to numerator. Right? Therefore, Young's modulus, we can write that is a P into L divided by A into delta L. The unit for Young's modulus is megapascal or Newton per millimeter square. Right? One simple problem. Why I am discussing this problem is, so you have to consider the cross-sectional area of the body. So depends upon it, you have to use the area of cross-section. Right? So here, the one link is there. In the link is subjected to tensile load. The link is subjected to tensile load. So here the link cross section is shown in the diagram. So AA is the link cross section at mid portion. That is the symbol of a revolved section. The revolved section means the sectional view was shown in the part itself, right? So this is a rectangle. So suppose you are cut this link, right? The cross section is a rectangle, right? And also the thickness of the link is 20 mm. This is section A. And the section B. So this is the section B. Suppose you are cut this portion in this point. So you will get the cross section like this. So that is a hollow rectangle. Cross section is a hollow rectangle. Got it? So this is the removed section. This is the removed section. Removed section means the sectional view is shown apart from the component. The sectional view shown apart from the component means that is a removed section, right? So from this removed section, we can able to visualize that is the cross section is a hollow rectangle. Hollow rectangle. So this mechanism is subject to tensile load. Now I'm going to read the problem. A cast iron link, as shown in figure, is required to transmit a steady tensile load of 45 kilonewton. Find the tensile stress induced in the link material at sections AA and BB. So they are asking what will the stresses at mid portion AA and end portions BB. Right. So we visualized the section at AA is a rectangle, and the section at BB is a hollow rectangle from the diagram given. So the section AA, I told you that there is a rectangular, right? What is the area? Rectangle, that is a breadth into thickness. That is a breadth is 45 mm, the thickness is 20 mm. Therefore, the area of cross section is 900 millimeter square. So you know that the stress is nothing but load by area. So here at the cross sectional area at AA is this one. Therefore, you go to put 900. So the stress value is 50 Newton per millimeter square. So it becomes 50 megapascal. The tensile stress at this section BB. The BB is that is hollow cross section, hollow rectangle. Okay, this is a rectangle. The material at top and bottom. Material is at top and bottom. The middle level there is no material. Middle level is hollow. So this is 20, right? The total Distance is 75. The mid portion is 40. The mid portion is 40. Therefore, the total length 75. We are subtracting the mid portion because there is no material. 75 minus 40. So here the thickness is 20. So finally, we'll get a 700 Newton per millimeter square. Right. So the stress at section BB is at the end. And the end of the link is load by area. So here the area is 700. Just now we have arrived. So the stress value is 64.3 Newton per millimeter square. 64.3 megapascal. 64.3 megapascal. Right. Why this shown this example is, so you have to give importance to find out the area of cross section of a component, whether it is a rectangle or a hollow rectangle or circular or hollow circular or square or parabolic or trapezoidal. You have to find out the area of cross section. According to that, you have to put the area. Then only you can get the exact value of stress. So this is another one example to understand the concept. So here the bolt nut assembly is fastened with the help of washer, right? That is, there are two plates. So one is base plate and another one is bottom plate. So here there are two washers. So one is the washer is held in between base plate and bottom plate. So this one, and another one is the washer is held in between nut and base plate. Nut and base plate. So this is the mechanism. Now we're going to read the problem. A rectangular base plate is fixed at each of its four corners by a 20 mm diameter bolt and a nut as shown in figure. The plate rests on washers of 20 mm internal diameter and 50 mm external diameter. The plate rests on the washer, that is a lower washer, that is a 22 mm internal diameter and 50 mm external diameter. And the copper washers which are placed between the nut and the plate are 22 mm internal diameter and 44 mm external diameter. So the copper washer is placed in between base plate and nut. The diameter is 22 mm and 44 mm external diameter. If the base plate carries a load of 120 kN, including self weight, which is equally distributed on the four corners, calculate the stress on the lower washers before the nuts are tightened. Before the nuts are tightened, what could be the stress in the upper and lower washers when the nuts are tightened so as to produce a tension of 5 kN on each plate? 5 kN on each plate. So first you go to read the problem and you go to thoroughly understand it. So here they are asking, what is the stress produced in the washers whenever the weight on the plate is above the washer? First thing, weight on the plate acting on the washer. Second thing, the nut is tightened. The nut is tightened. Tightened means the tightening tension is 5 kilonewton. This is also act over the nut. So they are asking two cases. What will be the stress when the nut is not tightened? And the second thing is, what will be the stress on the washer when the nut is tightened? Okay. So here, what kind of stress is produced over the washer means that is a compressive stress is produced over the washer, right? Because that is we are applying the load towards the component, Whenever the tightening of nut, it creates compressive stress over the washers, right? So here the dimensions are given. The stress on the lower washers before the nuts are tightened. So we know that the area of lower washers and upper washers, the area of lower washer is that is a hollow, that is a pi by 4 d2 square minus d1 square. The dimension is given in the problem. Therefore, 1583 millimeter square. That is the area of a lower washer. And upper washer is a pi by 4 d4 square minus d3 square. That is a 1140 millimeter square. That is the area of a upper washer. The upper washer, the diameter is smaller than the lower washer. Right? Since the load of 120 kilonewton on the 4 washers is equally distributed, therefore the load on each lower washer before the nuts are tightened. So the number of bolt in the assembly is 4. The total load is applied 120 kilonewton. Therefore, the load acting on each bolt, that is 120 by 4, that is 30 kilonewton, that is 30,000 Newton. Therefore, the stress on the washers before the nuts are tightened. So that is a load by area. So why the sigma C is there means that is a compressive stress. So load by area, the area of the lower washer, that is 1583, that is 18.95 Newton per millimeter square, that is equal to 18.95 megapascal. In another case, the stress on the upper washers when the nuts are tightened. Stress on the upper washer, the nuts are tightened. In the upper washer, only taking the load of initial load or a tension load by the nut, not the plate load. Therefore, the load is just 5000 Newton. So compressive stress on the upper washer, that is load by area 1140, that is a 4.38 Newton per millimeter square, that is 4.38 megapascal. This is the load due to initial tension on the nut or tightening of a nut. Right. Stress on the lower washers when the nuts are tightened. Stress on the lower washer when the nuts are tightened. So here the lower washer can take up the load by the tightening of the nut as well as the load due to the base plate, because the weight of the plate is acted over the washer. The weight of the plate acted over the washer is 30,000, and the initial load due to the tightening of nut, that is 5,000. Total load is 35,000. The area is 1583. That is the lower washer area. That is 22.11 Newton per millimeter square. So whenever the higher load is there, there will be the higher stresses, right? So why I solved this problem means, so you have to understood the nature of loading. So which component, which part of the uh, component take the maximum load and which part of the component take the minimum load. So like that you have to consider before solving. I want to share some objective type questions. The ultimate strength of steel in tension in comparison to shear. The ultimate strength of the steel in tension comparison to shear in the ratio of. So here in the case of stress strain diagram, so this point is ultimate strength. So they are asking the ratio comparison to shear. Okay. Uh, the usually the ultimate strength is high value, but the shear strength we usually take that is two-third. The two-third of the stress value. So here the answer is that is 3:2. That is the ultimate strength is 150 Newton per millimeter square, means the shear strength will be 100 Newton per millimeter square. That is the meaning of this 3:2. In another question, if a load W is applied instantaneously on a bar of cross-section A, then the stress induced on the bar in the worst case will be right. That is load by area, load by 2 area, 2 times load by area, 2 times load by area, a factor greater than unity, none of the above. So here the right answer is it is a 2W by E. So for instantaneous load, so you have to take that is a 2 times load for a stress calculation. In another question, if the longitudinal strain in the material is doubled in comparison to lateral strain, then ratio of modulus of rigidity to elasticity will be. So for that, what's the question? The longitudinal strain in material is doubled in comparison to a lateral strain. Then ratio of modulus of rigidity. What is the lateral strain? There is a change in lateral dimension by original lateral dimension. And here the important definition, that is the Poisson's ratio. The Poisson's ratio is lateral strain by linear strain. So that is the Poisson's ratio. Lateral strain by linear strain. The problem statement is the longitudinal strain in the material is doubled in comparison to lateral strain. So it means that the lateral strain is 1 means the linear strain is 2. So therefore, the Poisson's ratio, that is a 0.5. Poisson's ratio is a 0.5. Got it? They are asking the ratio of modulus of rigidity to the elasticity. So modulus of rigidity is N, modulus of elasticity is E. They are asking the ratio, that is the N by E. N by E. So there is one relationship between modulus of rigidity and modulus of elasticity, that is E, that is equal to 2N into 1 plus mu. 2N into 1 plus mu. This is the relationship between modulus of rigidity to the elasticity. Right? So they are asking, that is N by E. N by E. So N by E. So what happened now? So 1 by 2 of 1 plus mu. 1 by 2 of 1 plus mu. Okay. Therefore, 1 divided by 2 of that is 1 plus mu. 1 plus mu is 0.5. Therefore, 1.5. So 1.5 into 2, 3. Therefore, 1 by 3. So 1 by 3 is nothing but a 0.33. So answer is a 0.33. Have you got it? So like that you have to solve. In GATE examination, they won't ask the problem in direct way. Okay, they will ask only the indirect manner, right? So here there is no numerical values given, but with the help of the statement, we can find out the answers. So for that, you should know the basics very well. What is the basic? Nothing. The definition for Poisson's ratio is lateral strain by linear strain. So with the help of the statement, I formulated the value of 0.5. So after that, they are asking, that is a relationship between modulus of rigidity and Young's modulus. Elasticity is nothing but Young's modulus. Right? I know the relationship between Young's modulus and rigidity modulus. That is E equal to 2n of 1 plus mu. So from this, I simplified and got the value. So like that, you go to solve the problem. In another question, if the modulus of elasticity is equal to 0, modulus of elasticity is equal to 0, then the material is said to be. Modulus of elasticity is equal to 0, then the material is said to be. அது வந்து rigid மெட்டீரியலா இல்லை பிளாஸ்டிக் மெட்டீரியலா இல்லைனாக்கா ஃப்ளெக்சிபிள் மெட்டீரியலா ஆர் malleable material. Okay, so the modulus of elasticity is 0 means that is a plastic material. Modulus of elasticity, X modulus is 0 means that is the plastic material. Another question, if the stress applied to a member is doubled, stress applied to a member is doubled, the elastic strain energy will be, the elastic strain energy will be, right? So first we know that what is the equation for strain energy. Equation for strain energy. Okay. The strain energy is nothing but sigma square. Sigma square A into L. A into L divided by 2. This is the formula for the strain energy. Formula for the strain energy. Got it? If the stress applied to a member is doubled, the elastic strain energy. So here they are increasing the stress. Doubled. Doubled means instead of sigma, you have to put 2 sigma. Instead of sigma, you have to put 2 sigma. Right? 2 sigma square. Then what happens? So 2 square 4. 2 square 4. Okay. Therefore, the answer is what? 4 times increases. Got it? The S value is doubled. The S value is doubled means instead of sigma, you have to put 2 sigma. That's it. Right? Therefore, the S value is doubled means the strain energy becomes 4 times increases. The answer is B. In another question, if the area, length, and the stress to which a bar is subjected to be doubled, then the elastic strain energy of the bar will be. So now they are asking the stress value is doubled, the area is also doubled, the length is also doubled. The stress value is doubled means that is 4 times. The area is doubled means area is 2 times increases. The length is doubled means that is also 2 times increases. So finally, that is 16 times increases. Finally, 4 into 2, 8, and 8 into 2, 16. So 16 times increases. So usually all the competitive examinations as well as the gate examination, they will ask the problem. The next question, if the area of cross section of the wire is circular and if the radius of the circle decreases to half of its original value due to stretch of the wire by load, then the modulus of elasticity of wire. Then the modulus of elasticity of a wire. That is a good question. You must know that the modulus of elasticity is the material property. The modulus of elasticity is the material property. The material property will not change. The material property will not change. Right? Even though the size is decreases or the size is increases, the load is increases or load is decreases, whatever may be, right? The Young's modulus value will not change because the Young's modulus is a material property that is the constant. Therefore, answer is unaffected. Answer is unaffected. The other question, for a linearly elastic, isotropic, and homogeneous material, the number of elastic constants required to relate stress and straightness. Number of elastic constant required to relate stress and straightness. Right? For elastic, isotropic, homogeneous material. What are the elastic constant means? So one is Young's modulus, and another one is rigidity modulus, and another one is bulk modulus. Right? And one more term is that is the Poisson's ratio. Poisson's ratio. Therefore, the 4 constants. Okay, the answer is a 4. Because that is, you know that there is a Young's modulus and modulus of rigidity is related with E equal to 2n into 1 plus n. E equal to 2n into 1 plus n. And another one is relationship with Young's modulus and bulk modulus. That is E equal to 3k into 1 minus 2 mu. 3k minus 1 minus 2 mu. Right? So these things, the relationship between Young's modulus, rigidity modulus, bulk modulus, and the Parsons ratio. So therefore, the number of constant is next. On simple match the following. Tensile strength, impact strength, bending strength, and the fatigue strength. And the right hand side, the machine is there. Rotating bending machine, 3-point loading machine, universal loading machine, and a ISOD testing machine. So here, first you know that the impact strength. The impact strength is with the help of a ISOD testing machine, we can find it. Therefore, B is 4. B is and the tensile strength can be calculated by universal testing machine, UTM machine. So this is A. A is 3. The fatigue strength is a rotating bending machine. The fatigue strength is a rotating bending machine, that is B. And the bending strength can be calculated by 3-point loading machine. 3-point loading machine, that is C. Therefore, the answer is tensile strength, universal testing machine, impact strength, ISOD testing machine, bending strength, 3-point loading machine, and the fatigue strength, rotating bending machine. The next problem is the permissible stress in plates of joint through a pin as shown in given figure is 200 megapascal. Then the W will be. So this question is from Indian Engineering Services from 1999. So the plate width is there. The plate is having its own hole. Right, the plate thickness is 2 mm. The load is 2000 Newton. So for this mechanism, you can write the equation. So you know that the load is nothing but stress into area. Stress into area. Right, the stress is a tensile stress because the tensile load is applied. The area is W minus D into T. W minus D into T. So because the applied load is resisted by these portions. Applied load resisted by this portion. So this portion is having some hole. Therefore, you got to subtract the hole from this entire rectangle. So W, you got to subtract. The W is the total length, a total width. You got to subtract the diameter W minus D. Along with you got to multiply the thickness. So this is the thickness. This is the area of cross section. This is the area of a cross section. Okay. So they are asking the width. So from this equation, we know the load value, right, and stress value, diameter value, thickness value. Everything is given in the diagram. Therefore, after simplifying it, you can get the width, right? The W minus D equal to P divided by sigma T into T. So finally, you will get W minus D is 5 mm. Then W that is equal to 5 plus D. So that is 15 mm. Got it? This is from a Indian Engineering Services examination. Very old question paper. And this is from GATE 2017. GATE 2017. Look at the diagram. There are two holes. Two holes. So this is the width. Here also the tensile force is F. Here tensile force is F. Diameter of each hole is D. Diameter of each hole is D. Okay. Now I will read the statement of the problem. Consider the schematic of a riveted lap joint subjected to tensile load F as shown below. Let D be the diameter of the rivets and ST be the maximum permissible tensile stress. ST be the maximum permissible tensile stress in the plate. ST another stress. What should be the minimum value for the thickness of the plates to guard against the tensile failure of the plates? So they are asking the thickness of the plate, minimum thickness of the plate to avoid failure. Minimum thickness of the plate to avoid failure. Assume the plates to be identical. Assume the plates to be identical. Right? The same equation. So previously we are using, that is a load that is equal to water. That is W minus diameter into T into ST. This is between the rivets, right? So here, that is the W. There are two holes. So previously there are only one hole. Here there are two holes. Therefore W minus 2D. W minus 2D into thickness into stress. So they are asking the thickness. They are asking the thickness. So after simplifying the for thickness, the T that is equal to F divided by W minus 2D into ST. W minus 2D by ST. Okay. Right. So this is the right answer. So this is from GATE 2017. So again and again, I am telling that. So once you know the fundamental, you can solve any problem. You can solve any problem. That's why you have to study the problem for every topic in a in-depth manner. So next, that is the shear stress and the shear strain. I already told you that the shear stress is produced because of the shear force. The shear force is nothing but two tangential force acting in the opposite direction. Two tangential force acting in the opposite direction equal in magnitude. That is the shear force. So because of the shear force, the stress produced is called shear stress. The equation is same only. The equation is the same only. The shear stress is also, that is a load by area. Load by area. Here the resisting, the rivet is circular portion is resisting. Therefore, the area of cross section is pi by 4 d square. And the letter for shear stress is tau. Letter for shear stress is tau. Here the strain is measured, is an angular strain. That is a pi is the symbol for angular strain in the case of shear force mechanism. So here there are a concept, that is a single shear and double shear. So this is an example of double shear mechanism. That is a double cover butt joint. Double cover butt joint. Double cover means this is the plate, blue color plate and the rose color plate joined by means of two covers. The covers are shown in rose color. So this mechanism is the rivet is subject to double shear. The double shear means, so whenever the shear load is applied, so the failure of a rivet takes place at the two junctions, here as well as there, right? So the after failure, the diagram is shown here. That is, the failure takes place at the two portions. Therefore, we have to put two times area. We have to put two times area. Right? That is a double shear mechanism. One more example, the gudgeon pin used in engine piston assembly. Gudgeon pin used in engine piston assembly is also subject to double shear. Similarly, the knuckle pin in knuckle pin in a knuckle joint is subject to double shear. Right? This is the knuckle joint problem. A pull of 80 kilonewton is transmitted from a bar X to the bar Y through a pin as shown in figure. So this is the rod X, rod Y, right? So this is withstand by, joined by the means of this pin. If the maximum permissible tensile stress of the bar is 100 Newton per millimeter square and the permissible shear stress in the pin is 80 Newton per millimeter square, find the diameter of the bar under the pin. So very simple. So for first the diameter of the bar, that is the tensile stress is acting for diameter of the bar, right? So stress that is equal to load by area. So area that is equal to, that is a load by stress. You can find out the area. After the area, you can get the diameter, the pi by 4 d square. In similar manner, diameter of the pin is subjected to double shear. The double shear means that is the resisting area is the 2 times area of cross section, the 2 times pi by 4 dp square. The formula is same. CS that is equal to load by AP. So here you have to get the diameter of the pin after simplification. The diameter of the pin is 25.2 mm. And another problem, one simple problem, determine the force required to punch a hole of 20 mm diameter in a 5 mm thick plate with ultimate shear strength of 250 megapascal. So this is a punching problem. Okay, this is a plate. So we are going to make a punch here. Need to make a punch here, right? So the diameter is 20 mm and thickness is 5 mm. The shear strength is 250 megapascal, right? So the governing equation for the punching operation of plate is pi dt into tau u. Pi dt into tau u. So tau u is the shear strength. You know that the force is nothing but area into stress. The stress is tau u. The area is pi dt. Pi dt, the circumference. The circumference only the punching tool make the shear. Punching tool, it make the shear, that is a pi dt. So after substitution, you can get that is a force required to punch a hole on a plate is 78.53 kilonewton. Right. I stop with this. I will take the remaining topic in next classes. Thanks for attending this session.